Hello everyone and welcome back. To continue our study for some techniques in deep learning, we want to see a little bit about transfer learning. And let's see one example to see that how transfer learning can be used. Suppose that you are using the fashion means dataset that we talked about before, but you want to consider only 8 classes. For example, all classes except for sandals and shirts. As you may remember, in the means dataset, in fashion means dataset, we had 10 classes. Suppose we want to consider just 8 of them, and we want to exclude sandals and shirts. Someone builds and train a cross model on that set and got reasonable good performance, say that, for example, bigger than 90% accuracy. Let's call this model A. You now want to tackle a different task. You have images of sandals and shirts, and you want to train a binary classifier, say positive for shirts, negative for sandals. So, however, your dataset is quite small. You only have 200 labeled images. When you train a new model for this task, let's call this model B, with the same architecture as model A, it performs reasonably well. Say that 92.7 tasks, they are just 2 classes. You were hoping for more. So you realize that your task is quite similar to task A. So perhaps transfer learning can help. First, you need to load model A and create a new model based on model A's layers. Note that model A and model B, note that model A and model B on A now share some layers. When you train model B on A, it will also affect model A. If you want to avoid that, you need to colon model A before you reuse its layers. To do so, you must colon model A's architecture, then copy its weight. As you can see in the transfer learning, something that we do is that we have a model. That model was trained by somebody else, and we can see that on the task, which is similar to the task that we have, this model performed very well. And since the data set that we have available is small, and we do not want to train one more time, we can use the model which has been trained by somebody else for our tasks. For example, in this example that we talk about, the model that we had was trained for the classes which contain 8 classes. But here we have just 2 classes. Then here, as you can see, if we want to use model A for our purposes, we have to use all layers except the last layer, because when we have 8 classes, the last layer, as we explained before, softmax should be used. But since we want to use this model for binary classification, then the last layer should be assigned for the cases that you have 2 classes. For example, instead of softmax, you can use sigmoid. Then in this case, as you can see, when you train by changing the last layer, the weights that you have on model A will be changed. Then people save them somewhere, we can clone them somewhere, we do not want to lose that weights. Transfer learning is very popular technique that we have in deep learning. Another concept that we want to talk about, and it is very popular technique in deep learning, is autoencoder. Autoencoder are a type of artificial network. They are designed to encode and then decode input data. It means that we are using 2 networks, one of them for encoding, another for decoding. And the primary object of an autoencoder is to reconstruct its input data as accurately as possible, which means it learns to capture the most important features and patterns present in the input. If we want to see one example, suppose, for example, we have this written digit 4. If we use encoder, we can convert this to this line, and after that we will use decoder and we will reach to the same thing. The reason that people use autoencoder because we want to have a candidate for the input, and instead of using input directly, now we can use this candidate for all tasks. if I want to give you the idea that what this candidate means, suppose your input is this picture. You do not want to use this picture. You want to use, for example, a vector for your picture. Then you can use the concept of encoder. And this vector should keep important information of this picture. That's the reason that decoder can be used to give us something that we know this one should be similar to the input. This technique is very, again, popular in deep learning. Okay. If we want to see more about autoencoder, we can say that something that we have is like this procedure. It means that your input consists of some information. It can be vector, it can be pictures, and you are using encoder to convert this to a vector, for example. And after that, this vector will be used for other tasks. And always when we want to convert this in this vector to the output, we can use the concept of decoding. This technique is very popular. Okay, thank you.